Hi everybody, Jeff Mankowski, welcoming you back to the Maverick Statistics channel. In this video, we're going to go ahead and we're going to do a last example of standardization, and it's going to be similar to the last example and last video that we did, only this time we're going to talk about how we handle values that are in really funky places in the data set relative to the mean. So we're going to go ahead and let's bring one up on the screen and start the engine here. It looks like in this example we have three different students. They've taken three different exams. That's Joe, Beth, and Dave. And our job is to use standardization and figure out who had the best performance. They're also telling us all the data is from a sample, so we know what symbols to use. And what we'll do is we'll start by listing Joe, Beth, and Dave here. And I want you guys to take a minute, few minutes, pause the video, and I want you to work out the z-scores for all three people using the formula here. Let's write in our formula is z equals x minus x bar divided by s. And when you've got all three z-scores worked out, unpause, and then we're going to come back and we're going to talk about how do we evaluate the different z-scores. All right, welcome back. If you've just unpaused me, let's take a look at Joe's z-score, and we'll do the first one out here. We're going to say that we're standardizing the score of 100, and that's going to be equal to the 100 minus the 500. And then on the bottom, we have to be really careful because the curveball inside the exercise is they slipped us a variance for Joe. And remember, the formula needs standard deviation on the bottom. So we have to remember, how do we go back and forth from variance to standard deviation, because we're going to have to convert a lot of times in statistics. So important to remember that the standard deviation is equal to the square root of the variance. That means on the denominator here, we're going to write in a 5. When we standardize the score, we're going to end up with a negative 80. If we standardize Beth's score, we're going to have that the score of 300 was equal to the z-score of minus 4. And for Dave, we had standardized 250, and we ended up with a negative 5. Okay, so all of a sudden, all three z-scores are negative. How did that happen? What's going on? And more importantly, how do you evaluate it that way? The reason all three scores are negative is because in this situation, all three observations actually landed below the mean. And that's what gave us the negative signs. So how do you handle something like that? The answer is, when you see a negative, I want you to think of money. That's why I wrote in green on this one. And I want you to just say, would I rather owe somebody $80? Would I rather owe somebody $4, or would I rather owe somebody $5? And now the answer is a little bit more apparent. Most people probably wouldn't want to owe anybody any money. So the answer is that Beth actually did the best, and we'll talk about why. First, we're just going to mark in that Beth had the highest score. Now, the reason why Beth is the winner is because we actually want to end up choosing the z-score that's closest to 0, because that means we picked the student who actually had the highest score. That's how our mentality is going to operate when we're dealing with negative z's. And just something of interest to point out that'll help you as you operate standardization. In our formula, imagine what would have happened if we couldn't remember the difference between x and x bar and we got them switched by mistake. If we did that, that means in all three cases in the formulas, we would have had the x and the x bar switched, or the observation in the place where the average is supposed to be, and vice versa. And if that happened, it means that we would have ended up with three positive z-scores. We would have picked the exact wrong one. And then that would have really messed up our conclusion. So a little bit of notes here to help us recap, to know what to do when we get z-scores that are, all kinds of different values here, positive, negative, and stuff like that. Let's put in a few takeaways. We're going to say if we need a text box. Let's write right down here. If we have, we're going to put in negative z-scores. The winner is the score closest to 0. Now you have to be really careful too, because notice we're using score, right? And we're kind of implying that a high score is the best. We have to be also really careful to look at the context of the problem too, because it might be the case that a low score on something is actually better. So whatever the situation is that you're using standardization on, always make sure that you're looking at what the exercise is communicating. Look at the context and say, is this something that I'd actually want a lower score rather than a high score on, like a game of golf, for example. So again, if we're talking about scores on exams, if we have positive z-scores, the winner is the highest score. And when we say score, we're talking about z-score here. Okay, if we have a positive z-score and a negative z-score, then the winner is going to be straight away the highest z-score. So we're going to say winner is the highest z-score. Okay, so last possible situation, if we have z-scores that are all the same, then what do we do? Like if all three students scored like a z-score of -5, what would we do? And the answer is it's a tie. And we just don't have the information. We need to know more to figure out which student won. Like bring in maybe some outside information that can contribute to help us evaluate the students or what have you. But most of the time, if you have a z-score compared to other z-scores, they're all the exact same value with the same z coefficient, we're just going to go out and say it's a tie. They're all, one is as good as the other. So I hope this has helped you understand a little bit more about standardization and how to evaluate it. This is Jeff Mankowski with Maverick Statistics. I'll see you on the next video.